Hi, my name is Chris Lucian, and I'm the Director of Software Development at Hunter Industries. And today I wanted to talk a little bit about chaos engineering for teams and give you an idea of what that means to me and what it's like to apply engineering principles to team dynamics. So let's get right into it. I think that this will be really interesting for you in the audience, and please give me feedback if you have any for me, and yeah, we can talk about it online. So first of all, I'll talk a little bit about myself. I am a director for a team that works on international global scale IoT platforms. We use AWS, we mod program full time, and we are continuous improvement enthusiasts, if you like to take that definition. And a little bit of where this comes from is as we started mob programming 8 years ago, we had a small team for about 4 years. So we just did full-time mob programming in a team. We were very successful in that team. And you can see the picture of us there on the top, the smallest picture. And as we grew in scale, about 4 years ago, we decided to scale up that practice. We noticed that the complexities of interpersonal communication also grew fairly significantly during that time. And what we did is we kind of realized that there's a little bit to do with chaos engineering here. And so I'll read the definition just to kind of get us started. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. This comes from the principlesofchaos.org website where the principles are outlined. And it while this applies to computer systems, I think it also applies to interpersonal systems. So to draw the analogy, maybe we'll look at some of the tools. So here's a list, and there's many, many more in this. This is part of the Simian Army toolkit that Netflix open sourced, or many of the tools are open source. And so a lot of these things will dynamically change things around in the system to make sure that ensure resiliency. And so just like a server can go down in real life, maybe an EC2 instance goes down, so can a team member essentially put in their notice or the win the lottery factor, whatever it is, and kind of suddenly disappear, right? And so we have onboarding and offboarding to kind of manage that uncertainty, but we don't really know how good or bad it is. I mean, can you think of somebody in your organization right now that everybody would panic if they were suddenly no longer working for that company the next day? So that's where I draw the analogy between human systems and software systems, and why chaos engineering can make us more resilient as teams and as companies and as an industry. And a lot of it, many of these things kind of stem from potential siloing or communication issues. And so I kind of wanted to walk through all of the different areas in which these things can apply and bring up different things. So first, I'll go over some of the chaos engineering principles and run through that. So in that document, they talk about building a hypothesis around steady state behavior. So this picture here is what I call the Guitar Hero chart, and it is a list of deployments to different environments based on and whether it's successful. So these are actual pipeline runs. And so, one metric that a team might have is, can you deploy to production every day? So that's like a steady state thing, right? Then things like real world events might affect those metrics. So for example, if you had a really big silo on that team and they left or they switched teams or whatever, then all of a sudden that metric will falter, right? And so you can kind of easily see, if you really tried it, if you pulled that one person out, then you would end up seeing the effects. And unfortunately, because we're talking about resiliency in production, a lot of these experiments have to be run in production. So it's not like you're going to, just like computing systems and what Netflix does. So if you're watching a Netflix film and you are streaming video, they will shut down a server randomly, and it might have been the server that was streaming you that video. And it's amazing that you can continue watching the video and not see anything be a problem. And they do this in an automated way. And so that may apply to actually removing a member from the team as well, right? And I'll talk a little bit about the practical applications of this in a little bit, but the automate and run the experiments continuously. So a lot of this might be process rules because we're dealing with interpersonal relationships and things along those lines. But one thing we can do is we create automated systems to choose for us how we do these things. Finally, minimizing blast radius. So you want to make sure that in big changes, if you're going to make a change and test whether or not a single person may be a silo on a team, for example, by moving them to another team, creating a larger blast radius might be making them completely unavailable, right? So somebody going on vacation for 3 months might be a larger blast radius than them being across the room and available for questions, right? So I'll just kind of talk about chaos variables a little bit. So in that same document about the principles of chaos engineering, there's this idea of chaos variables and onboarding and so servers turning on and off, latency issues, things like that on the technical side might be comparable to onboarding and offboarding events, interpersonal conflict events, poor communication events that might be failures to communicate, and so on and so forth. So we want to minimize the impact of the experiments, and so I'll kind of go over some practical examples as we go forward and talk a little bit to some of those things. But it's crucial to make sure that everybody around you is also aware of the chaos engineering goals of these actions and how they can work. So first of all, we can talk about the examples that maybe I have stories around, and then how they modified chaos variables and changed the steady state behavior, and then what it meant moving on, and how it influenced changes around it. And some of these things just mean that we need to test them all the time, automated and continuously. And so very analogous to the Simian army systems. So intentionally switching team composition. So this is one that the team kind of came to on their own. They realized that siloing was becoming a bigger and bigger event. So the steady state is development gets done. You have maybe your KPIs of low bug rate and throughput and basically cycle time. And the chaos variable there is the people, right? And so if you change the people around, can you maintain that delivery rate? Another one is essentially, so this one's like randomized cross-boundary lean copies. So this is one that will really easily expose maybe interpersonal conflicts and things along those lines, because as you see different the lean coffee style, it's a Kanban conversation. You can look it up. But what's interesting about it is you get different groups of people that may even typically avoid each other kind of in the same room and expose those things and get past them. Another one that is really interesting is restricting the use of communication techniques. So, how does it work to build software when you're not allowed to verbally describe something and you must draw it? Or maybe you have to send it in chat. So this happens in mob programming a lot, where a navigator starts over navigating or getting exhausted from navigating. And so being remote, we've transitioned to a system for primarily chat-based in those situations. Another one is, basically another experiment to run, again, for the chaos engineering aspect, is creating a level playing field between different people. So in product ownership, you're typically outnumbered by the developers on your team, right? But having a retrospective where it's smaller, where it's just a few team members representing the team and a few product owners, that can be a really positive thing to balance out the level of communication. This is another one. I have a background in machine learning from my master's degree, and so the leave one out cross validation LOOCV. This can also work in human systems. So repetitive process. So leave one out means basically every time you have to do a repetitive process, you must expel one developer from the team so that they can go do something else while others do that process, right? That can expose a lot of things. Rebalance heroic work away from the hero. So if anybody acts in a heroic way, so that might be like staying late to work on something or something along those lines, then making it so that they're not allowed to be on that particular item for a while, right? So it disincentivizes heroism in that sense. But if it has to be done, it can get done. It just means that the aspect, whatever led that person to become the hero, can be rebalanced. Again, pushing responsibilities for releases to developers. So one key thing is a lot of times you might have a product management kind of a product owner type person dictating when the releases can go out, and so transitioning that to feature flagging, so they only can say when a feature is visible. They can't say when the software can be released. So this is going to be depending on where you are in your maturity with continuous delivery, but it's a good one. Going back to the leave one out cross validation, randomly deleting lines of code. So this is something where it's a human behavior of whether or not unit tests get written, things like that. But and a lot of times you can't really see whether or not a test positively or negatively impacts the system, but you can tell that if you leave a line of code or an expression out of the code and the tests all still pass, then that's an automated way of seeing like whether or not your quality practices are really being adopted by the rest of the team. So I'll go a little bit into practical solutions. So this is those were practical experiments, right? And then I wanted to talk about kind of practical solutions for resilience as well, and then maybe we can kind of wrap it up and talk a little bit about where to go next, right? So when responding to different things. So like a variable in chaos engineering is your team's resilience to new information, right? And so as new technologies come out, how hard is it for the team to learn? So one thing, practical thing to do to make your team more resilient to new and unknown is by basically incorporating high bandwidth learning, making sure that those things end up being good. Mod programming, I've talked a little bit about that earlier on. And I think that the main thing I want you to take away from this is that having a solo developer be responsible for something and never change them turns them into a silo. Having people in pairs lowers the risk, but it's still not resilient enough, in my opinion, and I've seen it go wrong still with pairs, and so mod programming distributes that. And when you have multiple mobs, then there's another part of that. Interpersonal safety. So this is one where it's working on the interpersonal safety. So again, we talked about maybe leveling the playing field and things along those lines, but making people safe through the different practices will allow, you'll see that and the yield from that by those lean coffees becoming more talkative and more loosely interpersonal, and that's really great. Technical safety, again, this is kind of more along the unit testing, refactoring side of things. And so those things make you more resilient to incoming demands and changes in priority and things along those lines. But the system has to be technically safe. You should be able to take new developers, put them on your project, and be comfortable in changes that they make to the system, because the system is going to have a safety net around it. And retrospectives is another one for essentially creating resilience around change in a system, especially things like the Satyr change model or other interpersonal pieces or even technical pieces. Retrospectives provide a large, essentially resiliency system around things that would otherwise be not discussed and then later cause problems for other people in general. Flat structures. So this one might be a little controversial, but I've been talking about it a little bit more lately. And this is the idea that if hierarchies actually end up creating some problems as well. Communication doesn't flow as freely. One test for this that you might run is how long does it take to get a command from the essentially a request from the highest level person all the way to the lowest level person. So that's kind of where I wanted to stop. I wanted to just say that it's been a pleasure talking to all of you, and I know we have a workshop after this. Again, I'm Chris Lucian, and you can find me on Twitter at Christoph Lucian. You can find me on the web at chrislucian.com, and I am a co-host for a podcast called The Mob Mentality Show. It's primarily about mob programming, but as you can see in the screenshot above, we talk about many things like the Satyr change model, zero bugs, servant leadership, things like that. And we'd be really interested if you came by and checked us out. And with that, I think that is it. So thank you very much, and have a great time running your chaos experiments, and please share with me your findings. I'd really like to hear about it. Thank you very much.